Hello, in this video I'm going to introduce my project, Semantically Informed, Data-Driven Factual Claim Verification. Our society is struggling with an unprecedented amount of falsehoods. The propagation of objectively incorrect information can negatively impact the operation of our society in many spheres. In political discourse, the misinformation can shake public confidence in government institutions, misguide political decisions, and reinforce belief in deceptive narratives. In fighting against misinformation, journalists and fact-checkers diligently vet claims by investigating relevant data and documents. The challenge is that human fact-checkers cannot keep up with the amount of falsehoods and the speed at which they spread. This challenge creates an opportunity for automated fact-checking systems. In recent years, researchers from various disciplines have come forward to assist fact-checkers by creating automated tools and apps. The process of automated fact-checking requires identifying and prioritizing claims to be checked, then conducting research and identifying evidence, understanding the context of information, and reasoning about what can be inferred from this evidence. Although relevant tools and techniques can assist fact-checking in various areas, effectiveness of the existing claim verification approaches is limited to repeated debunked claims, simple claims, and some of the statistical claims. Claim verification is a challenging task due to lack of authoritative data, difficulty in understanding the claim, and parsing the content of a claim to extract its properties. Translating complex claims to structured queries is also challenging. Our claim verification system consists of the following 5 stages: modeling factual claims, building an annotation tool, developing a semantic parser, building a claim to SQL parser, and finally building an analyzer to produce a claim verdict. We first analyze a dataset of fact-check claims to find a way of representing them in a structured way so that we can capture various aspects, such as entities involved and their relationships, quantities, points and intervals in time, comparisons, and so on. We examined a dataset of 3,600 fact-check claims one by one. We then grouped claims sharing common syntactic and semantic patterns. Our goal was to capture a common concept in which a given group of claims can be expressed. The outcome of this process was a set of 20 conceptualized claim categories. We then employed semantic frames for modeling these claim categories. We created 11 new frames and adopted 9 FrameNet frames. We built a publicly available and web-based frame annotation tool to aid annotating sentences. Our tool supports full-text annotation and encodes annotated sentences in the required XML format that is used in FrameNet frames. We fully annotated a dataset of 2,500 factual claims with a set of 3,600 frame instances. We used the transformer architecture and built a frame semantic parser that automatically detects frames and frame-specific entities called frame elements from factual claims. We injected our corpus of factual claim-specific frames and annotated dataset into FrameNet 1.7 dataset. We then trained our frame semantic parser on this new dataset. Our frame semantic parser achieved state-of-the-art performance in frame detection with a 92% F1 score and frame element detection with a 71 F1 score. Our semantic parser works as follows. For a given claim, it first identifies its corresponding frame or frames. Then for each frame, it identifies its frame elements. For instance, this claim belongs to a new frame that we created called vote. The vote in the verb form is the target word that prompts this frame. This frame has an agent who does the voting action, the frequency of the voting action, the position of the agent on this issue, and the issue that agent takes an action. These are the sum of these frame elements. We use corresponding text of these frame elements in generating SQL queries. For translating claims into SQL queries, we adapted and modified a text-to-SQL parser. We integrated the Congressional Voting Database for voting claims and a set of claim and SQL query pairs. We first generated 50 pairs of claim and SQL queries, then using data augmentation techniques, we increased the number to 250 pairs. While our model performed well on simple claims, it struggled with complex claims. We also observed some challenges with the verification results. For instance, while the corresponding query of this claim that Senator Richard Burr voted no on the Violence Against Women Act checks out on our database, the verdict from PolitiFact is different than ours. PolitiFact rated this statement as half-true. They confirmed that Burr did vote against the 2012 version of the law's reauthorization. However, they stated that 3 other times over 13 years, Burr voted for a reauthorization of the same law, and that's why they rated as half-true. So we updated the query by removing the position of Senator Burr, which was no. The query results show that PolitiFact is right, as he voted in favor of this law 3 other times in the last 13 years. For our future works, by taking these observations into account, we'll be working on our claim-to-SQL model to improve its performance. We will integrate new domains and we will create new claim query pairs for the new domains. And most importantly, we'll be creating a GUI where a user can perturbate the generated query to ensure the claim verification results. Thank you for watching.